Okay, so learning intention number 5, and we're going to be looking at the laws of exponents, and also we're going to be reviewing some like terms. So let's see. First, we got these 3 examples, and we are going to identify the coefficient, the base, and the exponent. Here, my friends, the coefficient is the numerical value, which is 2. The base is the number that is being raised to the whatever exponent. So the base is 2. Whoa, Bex. Like, the base and the coefficient are the same? Yeah. Exponent is the little number on top of your, it's like your conscious. Like, yes. Is this little 3 right here. Okay? With that in mind, let's move on to the next one. 2x to the 3rd power, if we want to say, but in reality is 2x raised to the exponent of 3. Okay? Why? Well, because the power is actually the whole thing. 2x to the 3rd is that. The power is 2x to the 3rd. Anyways, forget about that. You can still use it. So the coefficient here will be the numerical value. Okay, we're good with that. Now the base, remember, the base is what is being raised to. No, sorry. The base is the number that is going to be raised to the whatever exponent. So in here, the base becomes x, and the exponent becomes 3. In this example, and by the way, like 90% of the time, the base will be some type of variable. So in this case, the coefficient is the numerical value 4. The base is nothing more than x, y. Exponent, well, in this case, we have a 2 and we have an exponent of 5. Okay? So enough with that. Let us take a look at like terms. What are like terms? Like terms are terms that have the same variable, okay, and they must have the same exponent. Good, you're taking notes. Okay, so now let's take a look at some examples of like terms. For example, if you have, okay, example number 1. If you have 2 apples and then you pick up 3 more apples, you end up with 5 apples. See that? Now, let's say, example number 2. Let's say you have 2 apples and you pick up 3 more apples that are rotten. So let's put an R over here for rotten apples. It could have been a 2, a numerical value, it really doesn't matter, but I just want to make the point. Look, when you add this, you're going to end up with 2 apples and 3 rotten apples. Why? Well, no, you're not going to combine the good apples with the bad apples because you're not going to have bad apple or grad apples. No, you have 2 good apples and 3 rotten apples. That's it. It's like if you have an orange and a pineapple. What do you have? An orange and a pineapple. You don't have a patorange, or whatever you want to call it. Another example of like terms, okay? This time we're going to use x. So 2x plus 3x plus 6x to the 2nd power. What is this equal to? Well, 2x's, same variable? Yes. Yes. Same exponent? Yes. Yes. No. By the way, whenever you don't see a number, an exponent is always a 1, just in case. So 2x to the 1st plus 3x to the 1st. 2x's plus 3x's, 5x's. So you have 5x plus 6x squared. 6x squared. This, I was not able to combine this with them because unfortunately it does have the same the same variable, but the exponent is not the same. Another example. If I ask you what is 3x plus 9, please don't tell me it's 12x. Please don't tell me it's 12. Please don't even think about it. Variable, no variable. No variable. So then this is nothing more than 3x plus 9. If it was a minus, then 3x minus 9. As simple as that. So that's how you play with like terms. Right? So I hope you copy that. You have your notes. Remember, your notes are the most important tool for you to study. Okay, now that we have that out of the way, let us go over properties of exponents. Alright, so the first one that we're going to do is the product rule. Product rule. Okay? Eat Kobe. What are you doing? Do not eat anything. Hey, hey. Okay, goodbye. Alright, so where were we? Oh yeah, product rule. It says that if you have, let me change the color here. It says that if you have a number raised to a certain power multiplied by another number to another power, okay, then the result will be that base, you copy the base, raised to the sum of the exponents. That's what it is. Now let me give you an example. Example number 1. If you have 2 to the third power multiplied by 2 to the fourth power, you're going to end up with, you're not going to multiply 2 times 2 and it's not going to give you 4. No. 2 to the third power times 2 to the fourth power is 2 to the seventh power. What? Chillax. I'm going to explain to you. Look. 2 to the third power is nothing more than 2 times 2 times 2. 2 to the fourth power is 1, 2, 3, 4. This dot in the middle means multiplication, okay? So now let's see what we have. We have this times this. So we have 2 times 2 times 2 times 2 times 2 times 2 times 2. And remember what the exponent does. The exponent is the amount of times the base is going to be multiplied by itself. So this is 1, 2, 3, 4, 5, 6, 7. So therefore, 2 to the third times 2 to the fourth is 2 to the seventh. This is called the proof. When they ask you for mathematical evidence, boom, that's what you do. And it works for everything, okay? Okay, do we have another example? No. Alright, so enough with this. Now let's have the quotient rule. Oh, by the way, so in other words, when you multiply powers of the same base, you add the exponent and you keep the base. So now the quotient rule. Or the quotient law, whichever you want to call it. Rule, law. A rule is something that you follow. The law is something that you follow. Rules were meant to be broken. The law, I don't know if it was meant to be broken, but Okay, so we have the following. It says that if you are dividing x to the m by x to the n, and you know what? You don't even have to think that much about it. Look at this. The product rule says that when you multiply powers of the same base, You keep the base and you add the exponents. That's multiplication. You add the exponents. So in quotient, which is another fancy word for division, when you have a division, guess what you're gonna do? You're going to subtract. So the proof is the following. Let's have the same example. No, you want to have the same example? No, you don't want to have the same example. Let's see if I have another one. Example number 1. 3 to the 4th power divided by 3 to the 2nd power. Okay? So this is the same thing as 3 to the 4 minus 2, which is 3 to the 2nd power. The proof in here is the following. 3 to the 4th is 3 times 3 times 3 times 3 over 3 to the 2nd power is 3 times 3. See that? Expanding is always a good way to prove things. So let's see now. This is division. A fraction means division. So 3 divided by 3 is 1, because a number divided by itself is 1. Times 3 divided by 3 is 1. Okay? So you end up with 1 in the bottom because you run out of numbers. And look, here you end up with 3 times 3 is 3 to the 2nd power based on the product rule. Look, the exponent here is 1 and 1. So when you multiply powers of the same base, you add the exponents. Nice. Okay. One of my students told me, what was it? Oh yeah, why did Simba's dad died? Cause let me see. Cause he didn't move fast enough. He didn't move fast enough. Something like that. I don't know. Anyway, it's like why the chicken crossed the road. Alright, next rule. We're gonna have an exponent of an exponent. So let's use the black marker right here. Okay? Raising an exponent. Raising an exponent to an exponent. What? Easy. Let me see if I have an example. Well, the rule says the following. If you have a number raised to the power of m. Oh wow, sorry, gotta take this. Sorry, gotta take this. Hello? What's up? Sí, pero dime. No, vos decidí. Vaya pues. Alright, you see I can multitask. I answer the phone and I'm still writing the rule. So it says that when you raise a power to another, raise an exponent to another exponent, all you have to do is multiply the exponents. So in other words, that's the rule. Yeah, Bex, but like, okay, I get it, I understand like how to do it, but can you prove to me that that's really what it is? Sure. Look, example number 1, right? You see, do we have time? Yes. Example number 1. Let's say you have x to the 3rd power raised to the raised to the 4th power. Well, think about it this way. If you have x to the 4th power, that is the same thing as x times x times x times x, correct? Because that's x to the 4th power. Well, here I'm saying whatever is in parentheses, I'm raising to the 4th power. So in other words, this is the same thing. Remember, I'm raising to the 4th power. So this is the same thing as x to the 3rd, okay, times x to the 3rd, times x to the 3rd, times x to the 3rd. See? 1, 2, 3, 4 times I have what's in parentheses. If we go back to the product rule or law right here, it says that when you multiply powers of the same base, you copy the base and you add the exponents. 3, 6, 9, 12. X to the 12th power. Now let us not use the product rule, let us not expand, and let us just do it straightforward. So notice what you have here, a 3 and a 4. So what would be a shortcut to raise an exponent to another exponent? Well, I got a 12. How do I get 12 from here? Exactly, multiply the exponents. So then, x to the third to the fourth is nothing more than x to the 3 times 4, which is x to the 12th. Alright? Alright, let's look at another law. Any number, let me see, can I write here? Okay. Any number, okay, 0 exponent. Zero exponent law, if you want, okay? Hopefully you can see this. So, look, it says that any number raised to the 0 power is equal to 1. What? Yeah, any number raised to the 0 power is 1. So, how does that work? Oops, sorry. Okay, right here. Well, let's create an example based on the quotient rule. So let's say I have, really Kobe, listen, I don't want to hit you. What's wrong with you? No, you're not eating the marker. Go away. Thank you, bye. Okay, so let's say I have 3 to the 4th power divided by 3 to the 4th power. Not 34, to the 4th power, or to the exponent of 4. So if I follow the quotient rule, this one, I have to subtract the exponents, so I get 3 to the 0. Now let me prove this to you. 3 to the 4th power, no, Kobe! Don't eat the cable. 3 to the, what? Oh yeah, 3 to the 4th power is 3 times 3 times 3 times 3. Divided by 3 to the 4th power is 3 times 3 times 3 times 3. Okay, now I have expanded it. Now watch. 3 divided by 3 times 3 divided by 3 times 3 divided by 3 times 3 divided by 3. Yeah, I know, we get it, Bex. Like, come on, we're not that. You understand what I'm saying? I know, I'm just. So look, hey. So look, 1 times 1 times 1 times 1 is 1. So it is true that any number raised to the power of 0 is 1. But then again, why? Well, think. Any number divided by itself is 1. And look at this, 3 to the 4th divided by 3 to the 4th. They're the same number. So that's why it's 1. So, definition, any number raised to the power of 0, any number raised to an exponent of 0 will equal 1. Alright, I think I'm heading towards my last property, and then we're gonna do some problems, some nice exercises. If, I'm running out of paper, maybe I'm gonna have to do this in a different video. Okay. Negative exponents. Negative Alright, negative exponents. So, what happens when you have something like, no, first let us actually give you the definition. Or not definition, but like the practice. Look, if you have 3 to the negative 2, this is the same as 1 over 3 to the positive 2. If you have x to the negative 5, this is the same thing as 1 over x to the 5th. If you have 10 to the, Jesus Christ, to the negative 7, this is the same thing as 1 over 10 to the 7th. So, facts, right? Facts. So now, explanation. Sure. When can I get a negative exponent? Well, the quotient rule. For example, let's divide something. Let's say I have, I don't know, oh my God, 4 to the 3rd divided by 4 to the 5th power. Okay? So if we follow the quotient rule, we know that we have to subtract the exponents. So we have 4 to the negative 2. So how do we prove that 4 to the negative 2 is the same thing as 1 over 4 to the 2nd? Well, let us expand. That's how we prove, that's how we show work. Let us expand. Let me do it in a different color. Let me expand. 4 to the 3rd is nothing more than 4 times 4 times 4. 4 to the 5th is 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5. So now, let's see. Let us start eliminating. So 4 divided by 4 is 1 times 4 divided by 4 is 1 times 4 divided by 4 is 1. 1, right? Look, where does the 1 go? Top or bottom? Well, I ran out of 4s on the top. So it's 1. And what do I have left in the bottom? 4 times 4, which is 4 squared. Thus, I have proven that a negative exponent is the same thing as the reciprocal, but to the positive exponent. Cool? Alright, so let us start doing some problems, I hope. Let's see. For example, on the independent practice. So we're going to start with the independent practice. Independent practice. So I said, what is the product of negative? So the first exercise is negative 3x squared y times 5xy squared plus xy. Okay, here I have a typical example of the distributive property. One number, no sign, so times an addition of two other numbers. So to use the distributive property, remember you must multiply everything by everything. Got it? Good. La propiedad distributiva se multiplica todo por todo. So I'm going to start. So I'm going to take this number and I'm going to multiply by this number. So when you do multiply that, make sure that you multiply the coefficients, the base, and do the appropriate work with the exponents. So let's see now. Negative times positive is negative, right? So this will be negative. 3 times 5 is 15. So negative 15. X squared times x. Now this is an x to the first power, if you don't see the 1. So x squared times x to the first power is x to the third power. Y times y squared, this is a y to the first power as well. So y times y squared is y to the third. Negative times positive. Okay, look, I multiply by this one, now I'm going to multiply by this one. So negative times positive is negative. And I don't think it's going to fit, but I'm going to try it. So there is no number here. That means that this is an invisible one. So negative 3 times 1 is negative 3. X to the first power times x to the second power, that's x to the third power. And then y to the first times y to the first is, oh my god, y squared. Okay, next to the x to the third power. I'm sorry, didn't fit. Should have written smaller, right? So that takes care of the first problem. Let's go on to the second one. It says 12x to the third minus 6x squared plus 2x divided by 2x. Okay, listen to me. When you have an expression that has addition and subtraction and you're dividing by a single number or 2x, right? Everything gets divided by that number. In other words, you could rewrite this as 12x to the third divided by 2x minus 6x squared divided by 2x plus 2x divided by 2x. Okay? So let's think about it. Let's think it like that. So let's start. 12 divided by 2, 6. X to the third divided by x to the first. Remember what you do when you divide powers? You subtract the exponents. So 3 minus 1, because there's an invisible one here, is 2. Minus, why minus? Because negative divided by positive is negative. Minus, and then again, 6 divided by 2, 3. X squared divided by x to the first is x to the 2 minus 1. So that's x to the first. And then plus, divided by plus is plus. So plus 2x divided by 2x is a number divided by itself. Remember, this will be what? X to the 0 power, right? Which is 1. Or 2x divided by 2x. When you divide a number by itself, it's 1. And that would be the answer to that second problem. Third problem. 3x squared y to the fourth okay, times 4xy squared. 4xy squared. Well, one number. This is not 1, 2, 3 numbers. This is just one number. And this is just one number. If there was a plus or minus between them, that would make it more than 1. But everything here is together. So let's see. Let's multiply. 3 times 4, 12. X squared times x to the first is what? X. If you are confused, you go back to the product rule. So x squared times x to the first, x to the third, and then y to the fourth times y to the second is y to the sixth. So that's it. That's what you got. Okay. And I need more paper. Okay. Let us do one last exercise on this session because I'm not gonna be done. Okay. It says 45 a to the fourth b to the 3. So 45 a to the fourth b to the third minus 90 a to the third b divided by 15a to the second b. Okay. So once again, here is not one number, it's two numbers. Look, this one and this one, because they divided by a minus sign. Alright, so how do I tackle this problem? Well, remember, coefficients will be divided. Bases, exponents will be subtracted. So let's see, 45, and remember, is this divided by that and this also divided by that. So let's see now, 45 divided by 15 is 3. A to the 4 divided by a squared is a to the 4 minus 2. So that is a squared. The bell just rang. Now b to the third divided by b to the first is b squared. Okay, 3 minus 1 is 2. Minus 90 divided by 15 is what? 6. 6. A to the third divided by a squared is a to the first. Because 3 minus 2 is 1. And then b divided by b is 1. And remember, this is one number. So b divided by b, there is no addition or subtraction. So there is times 1. Oh my god, my dog just went crazy. Kobe. No. Okay. So 6a times 1 is 6a. You see what I gotta go through? Alright, so then at the end, my answer would be 3a squared b squared minus 6a, because 6a times 1 is 6a. Got it? So that's it. Alright, so I'm gonna stop right now because I need more paper, because as you can see, I kind of like run out of paper. And I'm gonna continue with this lesson number 5 later. Okay, let's do another exercise, another problem, okay? So I'm gonna use blue ink. Alright, so the next problem, okay? It says, what is 3 to the 4th, 3 to the 3rd times 3 to the 4th? Well, using the product rule, you know that this is 3 to the 7. I'm not gonna prove it, but I'm gonna tell you how to prove it. 3 to the 3rd is 3 times 3 times 3. And then 3 to the 4th is 3 times 3 times 3 times 3. So just, you could expand it right here and you will see that you will have 7, you will have 3 multiplied by itself 7 times. So that's why it's 3 to the 7. Next, it says express in exponential form with base 4. Okay. How can I express 16 as something like 4 to the something power? 4 times 4 is 16, so it's 4 to the second power. B, how can I express 64 as 4 to the something power? So 4 to the something power, let's see. 4 times 4 is 16, times 4 is 16. Oh my god, yes! 4 to the 3rd power. See? Yeah. Alright, so 4 to the 3rd power. Okay, so we're done with that. Alright, 27x to the 18th. Oh my god. Okay. So we have this exercise right here that it says 27 to the 18th power y to the 5th, okay, over 9x to the 6th y. So how can I express that? Well, first we deal with the coefficients. 27 divided by 9 is 3. And the 3 goes on top because this is the larger number. Got it? Okay. That was funny because it says 27x to the 18th. X is raised to the 18th. I'm sorry I made the mistake, but x is raised to the 18th. So x to the 18th divided by x to the 6th. Remember, it's like saying x times x times x times 18 times. So then what do I have? 18 minus 6 is 12. And then y to the 5th divided by y to the 1st, because there was no number there. That's y to the 4th, and that's the end of it. Simple, right? Remember, try to work these problems out before we do it. Before I do it, before you do it. Okay, next problem. Oh, by the way, each of these problems has y. Well, y means explain. So what you can say is the following. Well, we know that when we divide coefficients, okay, we just divide them. So 27 divided by 9 is 3. And then when you divide powers of the same base, we have to subtract. So x to the 18th divided by x to the 6th is 18 minus 6 is 12. And then 5 minus 1 is 4. And that's it. Okay. Next one. Negative 14a to the 2nd c to the 8th. So negative 14a to the 2nd c to the 8th divided by okay, divided by 7a to the 3rd c to the 2nd. Alright, so the whole thing is going to be negative anyways. So it's going to be negative. Okay, 14 divided by 7 is 2. A to the 2nd divided by a to the 3rd is a to the negative 1. Remember, the quotient rule says that you gotta subtract. So 2 minus 3 is negative 1. C to the 8 divided by c to the 2nd is c to the 6. Now, the moment that you've been waiting for. How can I rewrite this? Well, negative 2 is multiplying a to the negative 1. So it's going to be negative 2 times a to the negative 1. We already agree and we understood why it was a to the positive 1 times c to the 6. Remember, this is a multiplication. Negative 2 times the variable a to the negative 1 times the variable c to the 6th power. Okay then. And we understand why this is 1 over a to the 1st. So when we multiply, we get like negative 2 times 1 is negative 2 times c to the 6. But now, over what? Well, this is over 1 and this is over 1. So 1 times a is a times 1 is a. And that's what you get. Okay. Next problem. What is 3x to the 2nd? That's to the 2nd. I know it looks weird. 3x to the 2nd to the 3rd. Now I'm raising an exponent to another exponent. So basically, oh, by the way, This means do whatever is inside the parentheses 3 times. So I'm only gonna do this one time. I'm only gonna show you, and hopefully you understand one time. Whatever is inside the parentheses gets raised to the third power. So this is nothing more than 3a to the second times 3a to the second times 3a to the second. So 3 times 3 times 3 is 27. A to the second, a to the second, a to the second, that's a to the sixth. Got it? Or I could just done the following. 3 to the third power is 27. 8 to the second to the third, well, 2 times 3 is 6. So, nice. Alright, so, and basically that's what you have. Alright, so let's move on to the next problem. If I can just separate these pages because these pages are kind of like sticky. Okay. So next problem. So that is 2x to the third times 8x to the fifth divided by 4x to the sixth. Okay, so there is no sign like plus or minus, so basically you don't have to divide this by this and this by this. No, this is a multiplication. So let me multiply the top to make it easier. So 2 times 8 is 16. X to the third, x to the fifth, x to the eighth, divided by 4x to the sixth. Okay. 16 divided by 4 is 4. 8, x to the 8th and x to the 6th. That's x squared. Okay. Next problem. We have 3x squared. Let me see. 3x squared. Did we do that? Yeah, we did that. We have the next problem. 12w to the 9th y to the third divided by 3w to the third, sorry, divided by negative 3w to the third and y to the third. I know this is boring. I know, well, classes are boring. There's nothing we can do. Sorry. Oh, I need some water. Okay, so let's see. 12 divided positive divided by negative is negative. 12 divided by 3 is 4 on top. W9, W3, that's W6. And Y3, that's 1. How do I know that? Because y to the third divided by y to the third, they're the same number. A number divided by itself is 1. Okay. You know what? You are killing me. Again, bye. Okay, you wanna do this? Anyway, Kobe. So now this is the same thing as negative 4w to the 6. That's basically what it is. Okay, next exercise. Kobe? See, I told you markers. These markers are awesome. They get you like... Alright, so now we're done. And that's the end of learning intention number 5. Alright, so we're good. So now on the next episode of how do we pass our Common Core Algebra regions, we're gonna start with number 6, lesson number 6, and thank you.